All right, today we're jumping into one of the most important documents of the 21st century. It's just 9 pages long, but it proposed a totally radical new way to build digital money. We're talking, of course, about the Bitcoin Whitepaper.
So picture this. It's late 2008. The global financial system is absolutely melting down and nobody trusts the banks. Right then, a paper gets quietly posted to a cryptography mailing list. The author's name? Satoshi Nakamoto. To this day, nobody has a clue who they are. But their idea for a peer-to-peer electronic cash system, well, that was going to change everything.
Now, before we get to Satoshi's solution, we have to wrap our heads around the problem. And for decades, this one question had computer scientists totally stumped. See, if I have a digital file that represents $1, what's to stop me from sending a copy to you and then another copy to somebody else?
And that right there, that's the double spending problem. A physical coin, you can only hand it over once, but a digital one, you could copy it 1,000,000 times. Solving this was the huge roadblock, the main thing stopping anyone from creating digital cash that didn't need a bank in the middle checking every single transaction.
Okay, so that leads us right into our first big idea, the problem with digital trust. Satoshi's paper kicks off by looking at why we're so dependent on banks for everything online. The reason is simple. They're the trusted middleman that stops that exact double spending problem.
But, as the paper points out, this whole trust-based model, it's got some serious downsides. Because banks have to step in and solve arguments, transactions can actually be reversed. That whole process adds costs, which means buying a coffee or something super small online just isn't practical. On top of that, merchants have to grab more of our personal data to protect themselves, and everyone just kind of accepts that a little bit of fraud is going to happen. It's just the cost of doing business.
And this quote just perfectly sums up the mission. Satoshi basically says, look, what we really need is a system where we don't have to trust anyone. Instead, we can rely on something much stronger, pure, undeniable cryptographic proof. In other words, math.
So if you're going to replace trust with math, where do you even start? Well, you start by completely rethinking what an electronic coin even is. So for Section 2, let's see how Satoshi redefines digital money.
And this is where things get really cool. In Satoshi's system, a coin isn't just a file on a computer. It's more like a story. It's a continuous, unbroken chain of ownership, all proven with digital signatures. And you can think of a digital signature as your own personal, unforgeable wax seal. Every time a coin moves, the owner adds their seal, creating the next chapter in that coin's life story.
Let's just walk through it real quick. Owner 1 uses their secret private key to sign a message that basically says, I'm giving this coin to Owner 2. That signed message then gets tacked on to the end of the coin's history. Now, and this is key, only Owner 2 has the secret key to do the same thing for Owner 3. And here's the best part. Anyone, and I mean anyone, can look at this chain of signatures and prove the entire history of ownership, all the way back to the very beginning.
But wait a minute. Okay, this whole chain of signatures thing is great for proving who owns a coin, but it still doesn't stop Owner 1 from trying to be sneaky and signing over that same coin to 2 different people at once, which of course brings us right back to the main event, solving that double spend problem for good.
So how do you do it without a bank? Well, you've got 2 paths, right? There's the old way, the bank's way. You have one central authority controlling a private ledger. The big weakness? If that central point fails, the whole system goes down. Satoshi's idea is totally different. It's distributed. Its strength is that it's resilient, but the puzzle is still there. How do you stop double spending? The answer is beautifully simple. You make the ledger completely public.
And this, right here, is the big breakthrough. The core idea is that to prevent double spending without someone in charge, every single transaction has to be announced to everyone. The entire network of users needs a way to agree on one single shared history of every payment in the exact order that they happened. Because if everyone knows that Owner 1 already paid Owner 2, the network will just flat out reject any attempt to pay Owner 3 with that very same coin.
So how do you create this universal shared history? Satoshi proposes what's called a timestamp server. Basically, it scoops up a bunch of recent transactions, bundles them into a block, and creates a unique digital fingerprint of that block. That's a hash. Think of a hash like a fingerprint for data. If you change even a single comma in the block, the fingerprint changes completely. Then, and this is the genius part, it sticks the hash of the previous block into the new one, creating a chain. And there you have it, the blockchain.
Okay, but that just opens up another huge question, right? If there's no central company, no one in charge, who gets to be the timestamp server? Who actually gets to create the next block and add it to the chain? And that brings us to the engine of the entire system, proof of work. I mean, really think about it. This is the problem of getting a group to agree when there's no boss. If anyone could just add a block whenever they wanted, it would be absolute chaos. You need some way to make it difficult, to make people put some skin in the game, and to make sure that only one version of history moves forward.
Satoshi's solution is brilliant. It's called proof of work, and you can think of it like a massive, competitive, global lottery. All the computers on the network, called nodes, are racing to solve a really hard math puzzle. It takes a ton of electricity and computing power to find the answer, but it's super easy for everyone else to check if the answer is correct. The first one to find that solution, they win the right to add their block to the chain.
What this system so cleverly does is it turns computing power into voting power. It's basically one CPU, one vote. So the longest chain of blocks is always considered the true official one because it has the most computational work, the most energy invested in it. For an attacker to go back and change something in the past, they would have to redo all of that work and then outrace the entire honest network combined. It's an almost impossible task.
Okay, so we've got the theory down, but how does this all actually run day to day? And, maybe more importantly, why would anybody bother spending all this time and money to participate in the first place? Let's talk about the network and its incentives.
The whole process is actually a pretty elegant cycle. First, you send a transaction, and it gets blasted out to everybody on the network. The nodes, which we call miners, start collecting these transactions into a block and immediately start racing to solve that proof of work puzzle. As soon as one miner finds the solution, they broadcast their winning block, all the other nodes quickly check it, and if everything looks good, they add it to their copy of the chain and instantly start working on the next block, building right on top of the one that was just found.
So, what's in it for the miners? Why spend all that cash on computers and electricity? Well, here's the incentive. The very first transaction in every single new block is a special one. It creates brand new coins out of thin air and gives them to the miner who solved the puzzle. As Satoshi themselves put it, it's just like gold miners spending resources to pull new gold out of the ground and put it into circulation.
So let's bring this all home. When you put all these pieces together, the public ledger, the digital signatures, the proof of work competition, you get an entirely new kind of trust. It's not trust in a bank or a government, but trust in the math and the network itself.
And the security here isn't just a theory. It's based on pure probability. Just look at these numbers from the paper itself. If an attacker trying to create a fake chain is just one block behind the honest network, they've got about a 20% chance of catching up. But watch what happens as more blocks get added. After just 5 blocks, their chance drops to less than 0.1%. By 10 blocks, it's practically zero. That transaction is, for all intents and purposes, locked in stone.
So in the end, what did Satoshi actually build? It's a system where you just don't need that trusted middleman anymore, a system where transactions become pretty much impossible to reverse after just a little bit of time. It's strong, with no central server that can be attacked, and it's totally open. Anyone in the world can join or leave whenever they want, just by agreeing that the longest proof of work chain is the one true history.
In just 9 short pages, the Bitcoin Whitepaper didn't just propose a new type of cash. It gave the world a brand new way for a group of total strangers to agree on a single source of truth, all without needing to trust each other one bit. And that leaves us with one final, incredible question. If you can do that for money, what else can you build with it?